So hello everybody, I'm back again. So this is where we left off, and we were talking about bell-shaped curves, all right? Normal probability distribution. And here's an example. So you can go over that example at your leisure. So this is what a bell-shaped curve looks like. And this is going to determine how flat this is, right? Is going to determine the risk. We want this nice and tight, right around the mean. See, this is the mean, odd bar. This is the mean. So you notice how this is all spread out? Now, one standard deviation from the mean, right, here's the mean. One standard deviation from the mean takes up the 68% of the area under this curve. Now, the total area under this curve is equal to 1 or 100%, right? So two standard deviations gives you a 95% confidence interval. Okay, so that's 95%. And that's 95% of the area under the curve. And if we go out to 3 standard deviations from the mean, we're at 99.7 confident. Okay, and that takes up that much of the area. All right, so that's how that all works. But again, if this is spread out, the more it's spread out, the larger the standard deviation and the larger the risk. All right, now, we're going to talk about the coefficient of variation, and I will highlight this, all right, because this is important. We haven't talked about this yet, so we're going to talk about it now. You use the standard deviation to measure the risk when you're comparing two stocks and they have exactly the same expected returns. Is everyone clear? I'll say it again. You use the standard deviation to measure risk when you're looking at two different securities or stocks and they have the same expected return. Now, we can't do that with, we have to use the coefficient of variation when we have two stocks that have differing expected returns. So we got to go here. And I'm going to highlight this more now because this is important. All right. And that's bold. And I'm going to highlight that in yellow. See that? So that's important. Now, this is the equation for the coefficient of variation. All right. Now, you don't have to worry about it. It's quite simple. The math is very simple on this equation. And this is 8.4 in your book. All you do is take the standard deviation, okay, and put that in the numerator that you already calculated. Divide that by the expected return, R bar, and that gives you the coefficient of variation. So the way this works is the higher the coefficient of variation, the same as, with standard deviation, the more risk, okay? So the higher the standard deviation, the greater the risk. So let me do this. Higher coefficient variation, then the higher the risk. Okay? So we'll save that. And that's just like standard deviation. But you got to make sure now you look if they got different expected returns. Okay, so here's another example. Okay? Go over, this is example 8.7, and here's a personal finance example. So go over all these examples, right? If you have any questions, as usual, ask me. These are in your book, so if they're a little confusing, just get a hold of me. All right, so there's a term that's real important, and it's called the efficient portfolio. And the efficient portfolio is just as it's defined here. It is a portfolio that maximizes return for a given level of risk. Okay? Now, remember, now we're talking about a portfolio. What is a portfolio? More than one stock, many stocks, right? Remember I showed you mine? We had a portfolio, right? So what's the return on a portfolio? It's the weight of a part of the stock you have times its return plus the weight of the second stock, right? Blah, 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 dots here. So you take the weight, a percentage weight of each, and you multiply it by the return, okay? And basically, WJ is the percentage of the portfolio's total dollar value invested in the asset. And again, we add them up. You see sigma? This means add up, okay? Sigma means add up. Now, let me see if I can move this up a little. I want to move this up. And I'm going to see if I can put it in here. Sigma means add up. All right. So you got that. And I want to make sure everyone understands that this is sigma. All right. So I'll save that. All right. So here's another example. So we got a bunch of examples here. So please go over these carefully. They're in your book. If you have any questions, bug me. All right. All right. So here's historical returns, average returns, and standard deviation for portfolio X and Y. So remember what we're talking about now. Now this is a portfolio of 2 stocks. That's all. But a portfolio can have many stocks, right? So in this case, look, we have asset X and asset Y. See asset Y and asset X? Okay. All right, so here is a portfolio of 2 stocks, and they are stock X, stock Y. Everyone see that? X and Y. Here's the returns for each year. See that? Here's the returns for each year for those stocks. Now, what we're going to do is we're going to create a portfolio of both of those stocks. So, but it's going to be 50-50, equal chance of each. So we're going to combine 50% of this, you see that, and 50% of this, and we're going to get the return, the portfolio return. And everyone should see that it's 12%. Half of 8 is 4, and half of 16 is 8, okay? So you see that there, right? And now here's the 12. Now here's the average portfolio return. Everyone should notice right away that the average has got to be 12, right? So here's the average. It's going to be 12, right? And here's the standard deviation of the portfolio. Now, how much deviation do you see here? None. How much deviation? So this comes, the math tells you there's no deviation. All right? So everyone, I want to make sure everyone's clear about that, all right? So again, we got a portfolio of 2 stocks, X and Y. All right, so what is correlation? Correlation is a statistical measure of the relationship between any 2 series of numbers. And if something is positively correlated, it describes 2 series that move in the same direction. So, for instance, 2 airline stocks, right, would move in the same direction. And it's all a function of whatever happened in the economy, like the coronavirus. Now, with regard to that, all stocks moved down, right? But if 2 stocks are negatively correlated, they move in opposite directions. So if it's something's negatively correlated, one will move up, the other will move down, all right? They move in opposite directions, all right? So let's highlight this word here. This is important. All right, so the correlation coefficient is going to be a measure of the degree of the correlation between the 2 series. All right, so just want to make sure we're clear about that. So if 2 things are perfectly positively correlated, that means their coefficient is 1, okay? Both perfectly positive. They both go up or they both go down. This is a 1. And if they're perfectly negatively correlated, when one goes up, the other goes down. They're perfectly negatively correlated, right? And if they're uncorrelated, the correlation coefficient is 0, right? There's no correlation between them at all. Whoops, what happened here? Oh, God. All right, so we were here. All right, so we have a correlation coefficient of 0, all right? They're uncorrelated. So you'll notice here, here's two stocks, right? N and M, or M and N, that are perfectly positively correlated. When this goes up, that goes up. And when this goes down, that goes down, and right across, right? That means you're going to have large swings. Big positive gains, big negative gains, right? And again, big positive gains. Now look at perfectly negatively correlated. You're going to get an average return here, right? When this is down, this is up. When this is up, this is down. And when this is down, this is up. So you'll get an average here, right? You'll just get some average. All right, so how do you combine this? You diversify, right? And what is diversification? Diversification is reducing overall risk by basically combining or adding to a portfolio these assets that have the lowest possible correlation. You want low correlation. And so you're going to eliminate you're going to reduce overall variability, right? And that's important. You don't want a lot of variability, right? And you're trying to shoot them so that there's minimal variability there. So you can see here, here's F and G, and here's the portfolio of F and G, and it's almost perfectly negatively correlated. Notice how flat this curve almost is. Everyone see that? You know, you most likely would want it to be totally flat, but it's almost impossible to get that. All right, so here's a couple of examples here for you to go through. All right. All right, so here are the standard deviations and average returns for two portfolios. Now, this time we have 3 stocks here, X, Y, and Z. However, the portfolio was only made up of 2 out of the 3. X and Y in this case, right? See that? X and Y. And X and Z in this case. Now, you'll notice that the returns are 12 for each year, right? See that? So there's no standard deviation, as we said, right? 12. And the standard deviation 0. Now look at X and Z. Again, now look at the returns, the portfolio returns. They vary. See how they're varying? But the average is still 12. Look, let's add this up. 30, 42, 52, 60 divided by 5 is 12, right? But now look at the standard deviation. Everyone see that? So somebody tell me which one is more riskier. And you can clearly see there's no risk here, right? But there's plenty of risk right here. Look. So this is the more riskier portfolio, okay? Everyone see that? All right, so I just wanted to make that point. That's an important issue there. So in general, the lower the correlation between asset returns, the greater, and this is an important sentence, so the greater the risk reduction that investors can achieve by diversifying. So, of course, diversifying is an important concept, and everyone should be aware of that, okay? So you really want to make sure you're diversified. All right, so here's an example. This is example 8.12. Please go over that. So you can see here, look at the correlations between Here's one portfolio, the portfolio return, right? And plus or minus 1 is perfectly positive. 0 is uncorrelated. And low to high here is negatively correlated, right? So this is the ranges of returns. And here's the ranges of risks, okay? Here's the ranges of risk, low and high standard deviation, right? So from that, okay? So here's your possible correlations, right? So here's the returns, and here's the standard deviation. All right, so what I have too is I own personally stocks in other countries, so I'm internationally diversified. So the word international here is important, right? So I'll highlight that. That's important because you have to be really diversified all over the world, right? So that's the way a portfolio goes when you're diversified. Okay, so hold on. How'd that get red? I didn't want that red. I want that blue. All right, so whatever. All right, so it's important to be diversified across all borders, right? All countries. The only problem you got to deal with is I have to always worry about countries going, political risk, right? You don't know what you're heading for, okay? So there's a lot of risks that you got to worry about if you're going to, diversify internationally, right? All right, I'll pick up. I'm 18 minutes into this. I'll pick up on part 3. All right.